Hello everyone, welcome to this video. Here we will explain and show the challenge number 3, which consists of the management of a chatbot in Telegram and Watson IoT of the elective subject deepening in charge of the Professor Eduardo Barrera Guedron. We are third year mechatronics engineering students, and our working group consists of Javier Castañeda, who will explain the general logic of the polarity process in the PLC later language that was done in challenge 2, and the node network logic, and Brayan Alejandro Suarez, who will explain the communications architecture in Telegram, along with the conclusions of the project, and me, who will explain the creation of the bot along with the PLC communication architecture with Watson IoT. Okay. As an initial part of the work, that chatbot was created in Telegram to integrate with and control the polarity process through the boot file challenge that creates the bot and manage with many bots. Right. Once created, it is linked to Node-RED with being able to async commands that allow communication between the chatbot with the factory I/O SN. Next, my colleague Javier will explain the connection process with Node-RED.
Well, thank you, Anil. Now, in Node-RED, we have two Node-REDs. We have Node-RED local and the cloud Node-RED. These are connected by IBM Watson platform and Net2 PLC. Right? In the local, we receive the things of the cloud and we send the things of the local by these nodes. These nodes of this farm are coming from the TIA portal and PLC. Now, in the Node-RED code, we have the nodes that receive and send the things for the other Node-RED, and we have here the applause for the dashboard of the Node-RED. And now I'm going to explain the logic that we have in TIA portal, the data. We have one segment that is going to connect with factory. Later, we have the segment 2 that is the bus feeder, and it's activate with sets and resets, like you see, and program blocks. This segment have the bus feeder. Now, in the third segment, we have the pallet feeder, and it's acting like the other segment that I said. And last one, we have the fourth segment, that is the control, when we have the reset, the stop, and the function of move that it's going to control all the other wires.
This type of architecture is based on reading and sending commands related to the network node. So when TIA portal is configured to the PLC, it's connected to the Net2 PLC and sends data to the network node.
Thank you very much, Alejo. Now I will explain through the following image provided by Professor Eduardo the communication architecture between Watson IoT with Node-RED and TIA portal. First, the logic is loaded in TIA portal to activate the simulation with PLC. Then Net2 PLC is connected to make the connection between Node-RED and TIA portal. It is important to note that Node-RED is installed on the IBM cloud computer with the Watson IoT platform, and as a final part shows the control panel designed on the Node-RED dashboard, where all the information with control and monitoring, pilot lights, and historical communication between these parts as bidirectional, and sometimes delays may occur in the signals. Okay, Now we will explain in this section of the control panel. You can see the start, stop and reset buttons, which will allow the control of the polarity process. Next to the buttons you can see 4 drop-down menus. The first menu refers to sensors that there are in the second menu. The actors are found. The third shows the status of the process, that is, if it is in manual or automatic. And finally, the fourth menu shows which conveyor belt is activated. Each of these variables has its respective LED that switches from green to red according to its logic state. Okay. In the upper left part of the screen there is a hamburger menu where the history section of each of the variables is shown.
Okay, the IBM interface shows the ordering of data through the IoT communication, while historical data is present. The virtual start, stop, and reset buttons, and 3 physical buttons for auto and manual states are present. The IBM show the history of recent data.
Last one, we have the control by the bot. Now we are going to express the bot and the control this. Now we are going to say hello to the belt, and this is going to answer that hello that we are going to say that. Now we are going to say start, and this is going to start in the band. We are going to see that the band is answered to us, and we have the other option to say stop, and like you see, the band is going to stop.
Okay, our industrial control system has still very complex industrial process. They detect on current problems, and they can be as a organization for this, a generation of process and product. Therefore, the security of system must be constantly assessed to identify potential breach. Security environment for all infrastructure that is critical to organization business. The impact of best of class systems security flows have been identified, such as the lack of segmentation of the services that are available, the use of weak or default passwords, well, the lack of daring and sense of security patch that put of eminent risk and the CEA of information in replace systems.
Okay, thank you very much everyone for your attention and watch this video.